So start. So today we will be looking at time series. Time series, or also we can say forecasting. Forecasting is nothing but given the data of the past, how you will predict the uh, data for the future. So before even starting with like forecasting, let us understand how time series problems are different um, than the problems that we saw till now. So till now we saw a lot of machine learning algorithms, which which we can divide into two parts. So we saw some supervised ML algorithms. We saw some supervised algorithms like uh, so SLR, MLR, and in that you had given X, and you also had the Y known, which you want to predict. So what you were doing is you were predicting Y with X. So given X, you were predicting Y. In the case of time series data, there is only Y. There is no concept of X. Uh, if I want to give an example, think of a data. Let's say I am recording my weights. So let's say today it's 49.5. Uh, sorry, let's say 15 days back it was 49.5. Then it is 49.2. Then let's say it's 49.3 and so on. Okay. So if you're so this is a kind of an example of time series. Here data is arranged according to the indexes. So this data, which is 10 days back, this data is 9 days back, this data is 8 days back. Okay. It's arranged according to the sequence. So let me take. Okay. Now, looking at the weights, you can say that there is a decreasing trend. So over time, plot the weight over time. It started somewhere from 49.5 and then it is decreasing trend. Okay. Maybe it would saturate, but yeah, there is a kind of decreasing trend, right? But if I do not keep the index, if I don't uh, keep the order, so here in the case of time series, order is very important. We need to maintain the particular order. If we mess up with the order, so even though the data is same, now you may think it as an increasing trend. So it would give you a wrong result. Let's say I'm following a diet and I am recording my weights. If I mess up with the order, what I would think is, instead of uh, seeing the decreasing trend, I would see an increasing trend, which is not correct judgment that I should, or correct interpretation of it. So in the case of time series, the indexes or the order is very, very important. Data need to be correctly collected according to the time, and we need to arrange it with respect to those timestamps or indexes. And yeah, the order is the crucial point in this kind of data. We did not have such data earlier, but in the case of time series data, order is very, very important. For example, let's take a stock example. Okay, when you're doing the stock analysis, you plot it over time, and you can see like what is the stock prices. Okay, if I do not keep this order, okay, now I can see that there is an increasing trend and there is a decrease. So maybe I would buy somewhere here and sell it when it's increasing. Let's say I don't maintain the order and I just plot it anyhow, then it would just give me a wrong trend altogether, which is not something that I would want. So, in the case of time series, it's very, very important to keep the track of the keep the track of when this data is collected, how the so basically timestamp or the index or the order need to be there in this data. That's why it's called time series data. Then coming back to our ML algorithm, we also had the unsupervised ones, where you had only X, and here you could change the order. Okay. So example of this is like clustering, random forest, decision tree. All these are example of this unsupervised. So not random forest. Random forest tree is supervised. Sorry. The clustering algorithms comes under unsupervised. So where you don't have the concept of why, and but there you could change the order. In this case, you can't change the. Let me write it down. For the time series, there is no concept of x, right? The one point, and secondly, order is very important. Can't stress enough on this point, but that's the data. If you lose the order, you lost the data. The whole data is useless then. If order is not met. So now you see we have these three types of algorithms. One which is supervised, where you have both x and y, then unsupervised, where you have only x. Now we are looking into time series where you have only y. Okay? These are only three uh, types of problems that you can broadly classify as set into. So again, I'm saying in time series data, information is in the sequence. If sequence is lost, data is useless. Sequence should not be altered, and there is only y. We do not have x. So, so how we basically do the so what we are gonna do? I'll just quickly tell you. So we will take the past data. We will be building model using that, and then what we will do is we will do the forecast. For example, given the temperature of let's say past 100 days, Can I predict the temperature today? Today or maybe let's say tomorrow. Can I predict the temperature tomorrow? So these are the kind of problems that we would be solving. Given the stock prices of all the um, of past, can I predict stock price for tomorrow? Given the um, so can you think of any example where you need the time series?
We have this biodiversity predictions that we use.
Right. So given the growth, or I mean, the numbers in the past, how many will be in the future?
It's more of different temperature and climate of the past to
Okay,
predict whether that plant will be there in the future.
okay, okay. Yeah, that can also come in the forecast. Yes. Even the population trend will come. So given the data of the past, what would be population tomorrow? Or what would be the growth rate tomorrow? All these are um, time series or time series data. So let me just so for the time series data, we use this line plot. Line plot is nothing but literally draw the line in setup. So it is always between your y and time. Okay. So join the points with line. This is the line plot. So x axis is always time. Y axis is your variable that you want to predict. So it's important. This kind of graph is important in the time series analysis. It tells you about the pattern of the quantity over time. It it gives you a quick like uh, overview or intuition about like how your data trend is. It tells you basically it tells you the trend of the data. So, but actual line plot in the actual line plot will look something like this, like this. Even the heartbeat data, right? So, or it could be like this. Okay. So, for the line plot, we may get many sharp edges, which makes it difficult to analyze. So that is why we do the smoothing. So, for example, if I look at this data, uh, or let us say, if I look at this data, I do not know exactly what, like, we can figure it out, but it's not very straightforward. But if I smoothen the data, then you can see the trend is like this. It becomes more clear after smoothing what exactly the trend is, rather than unsmoothen data. So that's why in order to understand the trend, we what we do is we take the moving average, or we use the smoothing technique. So Till now, it's clear what we are trying to do, why we are trying to.
Yes.
Then we will be using smoothing techniques in order to uh, understand the data better, because this sharp edges, it will make it little difficult to understand the trend of the data. So what we will do is we will do the smoothing. There are many smoothing techniques. We will be seeing those, but as of now, we will just look into one, and then we will understand the how we decompose the data basically. So first, let us see the moving average. There are four smoothing uh, four techniques we are gonna study. So moving average is first. So it's this whole time series part. It's not difficult, but it is just a lot of information. So bear with me. So in order to get rid of the sharp edges, instead of looking at the individual observations, we will try to average it out, and we will what we will do is we will average out each local neighborhood, so that those sharp edges are gone and you will have a smooth curve. So first thing you need to do is fix a window size. Now which window size to take? As we have seen it before, try many window size, see which fits your data and take that. So but as of now, let us say 3 is the window size. Okay. So now I have data y1, y2 up to y100. Okay. Now let's say I keep the window size 3. Okay. So first thing is I need to fix I have the data, and now I need to fix the window size. Let me keep window size 3. Okay. Now the smoothened version would be the first. Um, Let me write. Okay. Let's say I have 100 days of temperature data. Now, what you would do is you would take the average. So, in order to find what is the value for uh, what is the averaged out value for y2, what you will do is you will take basically the average of adjacent totally 3 points. So you would take the window of 1, 2, 3 data points, and then you would take the average. So the smoother version of y2 would be equal to y2 plus y3 plus y1. Let me write it with a sequence. So y1 plus y2 plus y3 divided by 3. That's your smoothened version for the y2. Now in order to calculate for the y3, just move this window to y3. So for y3, your smoothened version would be what it would be? Any guess?
Y2, Y3, Y4.
Yeah, it would be y2 plus y3 plus y4 divided by 3. So like this, you would calculate for each data point. Now tell me what would be for y1 and y. leave y100, but tell me for y1. So as like if I keep this window here, there is no data on the left of y1. So as there is no data here, what we would do is we won't take the smoothened version of y1, we would take y1 as it is. So we will take y1 as it is. Y2, from y2 we would take the averaged value. Okay. So so the new series would be, so y1 and y100 we will keep as it is. We won't do any changes over there. So now our new series would be y1 plus y2 plus y3 divided by 3. Then y2 plus y3 plus y4 divided by 3, and so on up to y100. Then, so any doubt till here? Is it clear?
And what will be y100?
Yeah, so when you will get the data, for example, let's take the weight data. Okay, so what you said is day one, my like weight is some value, let's say 50. Day two is 50.1. Like that, let's say you calculated, you basically maintain the weight over for, let's say, 100 days. Okay, then your y1 would be the same, day 1 data. Your y100 would be day 100 data, but for the day 2, 3, 4, 5, you would smoothen it out using the local average, so that if there are any sharp edges, you can get rid of this. Is it clear now?
Yes, yes.
So out of your data, the first data and last data, you don't change anything about it, but the middle data, you will take the average. How you will take averages? Take a window. And currently I have taken the window of 2, 3. You can take it out, take window like 5, or yeah, so 5, 4, like that. So
Hmm.
once you take the window, move the window. When you keep the window, the center of the window at y2, then you will calculate the y2 average. Move it to y3, take the average, y2 plus y3 plus y4, average of those would be your new y3. Then move it to y4, take the average of these three, and then that would be your new average. Each time, this is your window at present. Each time you will move the window and take the average, and that uh, you will replace with this middle value. Clear?
Yes.
Now, in case you have the window size even, so let's say window size 4, then what would happen is you will get one window like this and another window like this, and you don't know which one to choose, because this particular window let's say I'm calculating for Y3. Okay. This particular window focuses on left hand side more, and this window focuses on right hand side more. So which one to choose, we do not know. So what we would do is we'll take this window, take the average of it. So y1 plus y2 plus y3 plus y4. Okay. And we will multiply it by half, and then again we would take this window, multiply by half. This is only when you have even number of window size, but majority times we just take the odd number, so this problem doesn't occur. Okay. And let's say if my window size is 5, okay, so y1, y2, y3, y4, y5, y6, that's it. Okay. Now if I draw the window, so this is my center value, and this is how the window would look. Now if I start if I shift it to y2, there is no data on the left. Okay, there is no y0, so we can't take the average for y2. Here we need to start taking the average from y3. So after y3 you will go to y4, then y5, then y6. Okay, you will just then shift the window. Okay, but here you can't take the average out for average value for y1. You can't take the average for y2. All the data need to be there in order to take the average. So here you will start with from y3. So what will be your uh, data? So y1 would be as it is, y2 would be as it is, but for y3 you will have average y1 plus y2 plus y3 plus y4 plus y5 divided by 5. This is your average for y3. And what is the appropriate window size? That will be based on your data. We can see the period of the data, and period of the data would be window size. And period is nothing but how each time your value changes. Let me just give you an example. Let's say uh, let's say for the AC price. Okay, let's say AC price is my uh, data. Okay, over time, if you see the in January, Feb, okay, in January the prices of AC would be slightly low. February may be slightly increased. March you will have higher number of people purchasing. April also high number of people purchasing. May also may be high number of people. From June there would be a drop. Okay. July also less number of people will purchase. August also, August, September, October, even in December maybe the lowest number of people will purchase. Again, so the prices would be low. And then again in month of January, slight increase would be there. So now you can see the trend over here. Okay, and this trend would be repeated. Now your this trend is repeating after 12 months. So in the January sell was low, again in the January sell will be low. In the May this sell is at the peak, or the prices are at the peak. Here also the prices. As there is more demand in May, the prices would be high in May. So you would see this trend over and over and over the years. Okay, so this trend is repeating after 12 months. So for this data, the window would be of 12. Okay, so your so based on the data, we can see that after a certain period, your data is repeating, and that data that particular period would be our window size. So that's why window size is dependent on your data, and your window size is nothing but the period for after which the data is repeated. So any doubt till now? If this much is clear, a lot of things would be easy.
Fine, fine.
Then let us see. So then the next part we would be seeing is decomposition of time series. Okay. So we would decompose the time series in three parts. First is trend, second is seasonality, and third is noise. So let's see each one of these one by one. So the first is trend. Trend is nothing but how the values are changed over time due to some external. It could be some external factor, or it could be, so anything can cause the change over time. So for example, your stock values, right? It could go up, then it could come down. So this this is a trend in the in your stock cycles. And then there is a seasonality. Seasonality is like every each time during the Diwali, the gold prices would be high, or each time in even for the fruits, right? Each time in the like when the mango season starts, uh, then the prices would be high. Then it would be, so first your mango prices would be high, then it would uh, come down like anything, then again it would see a slight at the, like when it's about to end, maybe a slight increase, but yeah, it's this is the kind of trend that we have each year. So when the mango season start, you will have the highest price to pay, then the price would decrease over time, and then again, like maybe you would see this increase or maybe not, but yeah, so after a certain point there is decrease in the time, decrease in the uh, prices, then maybe it's not available, so you won't have the prices for certain amount a certain amount of time, and then again you would see the increase and decrease. So this trend will go on repeating. Okay, so this kind of this this is trend, but repetition of, like, so my data goes like this is a trend, but each time it takes values like this. So each time it's repeating it like this. Uh, Let me just show you the decomposition. Just a second. Let me just share this. Okay, can you see the screen? So we'll look at this. Okay, this is the footfall data. Footfall means how many people visited the store. This is for the Walmart. So you can see these like here 2,000 people visited. So this is like it has some fluctuations. Now, if you just look at the first data, it is not very clear what exactly is the trend of the data. So that's why we do the smoothing in order to understand how exactly your data is changing over time. And this smoothing helps you understand what exactly is trend. So you can see this is all time low footfall. Then again, it's increasing and it is still increasing. So you can see overall trend, overall increase and decrease in the footfall, seeing just the trend part. Now seasonality is like like how if you see over the time it would be having some pattern repeated. So for example, look at this data. So uh, maybe for example in the December, maybe that people uh, are more likely to shop because that's their holiday season, everyone is free and everyone would be like shopping. So maybe in the December you would have more number of footfall because more number of people. So you can maybe correspond each peak here with a particular festival. For example, December. So in for them, November, December is the season where you have the most number of like majority of them their holidays comes in November. So maybe that time they will shop more and less over the years. Over the other month, they might shop less. So like that, you would have some trend over like so this is the overall trend. People used to shop less or come to the Walmart less. Then they reached all-time low somewhere here, and then it is now increasing continuously. And this is seasonality means over the year how like which kind of trend is repeating. So for example, in this particular month, there is more likely that people will come to visit your store. For example, in Diwali, majority people will buy new clothes. So you can see so many people in the Zudio or Trends purchasing in that particular time. So this would be repeated every year. So every year in Diwali, you will see sudden hike. Every year in Navratri, you will see sudden hike. So like that, this kind of uh, this particular uh, uh, thing will happen each year. That is called seasonality. So in every year, this in this particular season, there would be certain increase, decrease, whatever it would. So this is called seasonality. So how season wise your data is changing, and trend will tell you how overall data is changing. So overall, there were less number of footfall. You reached your all-time low here, and now it's continuously increasing. Seasonality will tell you how the data is repeating, the pattern in the data is repeating each year. And noise is nothing but the randomness in the data. So if you basically take the raw data, you subtract the trend, you subtract the seasonality from it, whatever you are left with is nothing but the noise. So when we get time series data, we try to separate these three components: trend, seasonality, and noise. Let me share that. Okay, so in the decomposition, we decompose the time series data into three parts. One is trend, another one is seasonality, and third thing is noise. We decompose our data into these three parts. The trend is nothing but over time what is happening to the data. It gives you an overall story. Seasonality is in each season when it peaks and when it falls. So it explains the periodicity of the data. So first let us see how to find the trend. Okay. So do you have any idea how to find the trend? I'm asking because you already know the answer. Okay. Take the data and then smoothen the data using the moving average and with appropriate window size, and that would be the trend. So for trend, first take the data, take the moving average, and that is your trend. So any doubt till now? Any question till now?
No.
So that's uh, your moving average. Now uh, let's see how to find the seasonality. So let me just tell you, in order to find the trend, you take y1. Let's say your window size is 3, then y1 plus y2 plus y3 divided by 3 on up to 500. This is your trend. Now let's say we collect data uh, every month for 10 years. Then we will have 120 data points. So for every month 10 years, I'm collecting the data. I will have 120 data points. So this is my data y1, y2 up to y100, and I will subtract the trend z1, z2 up to z100. This is my raw data, and then this is my trend. I'm subtracting the trend from the data. What I'm left with, let me call those alpha 1, alpha 2 up to, sorry, not 100. We have data up to 120. Okay. Now, this data is nothing, whatever is remaining is nothing but seasonality plus noise. So, your data is nothing but the sum of trend plus seasonality plus noise. Okay. Now, if you subtract the trend from the data, if you subtract the trend, what you are left with is seasonality plus noise. Okay. That's what I'm saying. If I subtract the trend, what I'm left with is seasonality plus. How do we do the subtraction? So let's say for y1, you have same value y1. So this would be 0. Then next, from y2, you will subtract y1 plus y2 plus y3 divided by 3. That would be your z2. Okay. So like that, you would get the values, sorry, alpha 2, alpha 2. So like this, you will get the 120 values. Those values are nothing but sum of your seasonality and noise. Now, let's say we want to calculate the January month data. So each year you will have the January data. So what is my January data? It is alpha 1, then alpha 13 is the January data, then alpha 25 is January data, and so on up to alpha 109. Okay, this is your January data. So for each year, January month data you would have, and now this would give you, this is the seasonality plus noise data. Okay. Now in order to calculate the seasonality, average out these values, you average out. Okay, that is your seasonality. Okay, so in order to calculate the seasonality, average out the values for every month. What is the January value? Collect all those values and average those out. That's your seasonality. So what would be the seasonality for December value? For December, it would be alpha 12, alpha 24, alpha 36, and so on up to alpha 120. Okay, take the average of this. Okay, take the average of this. This is your seasonality for December. Similarly, if you want to calculate for February, take alpha 2 plus alpha 14 plus alpha 26, and so on up to alpha 110. Okay, so this would be your divided by 12 would be your, because this, why 12? Because this is 12 years of data. Sorry, divided by 10 because it's 10 years of data. Okay, so divided by 10, and then you will have seasonality for December. Sorry, for February. Now you have raw data, you have trend, you have seasonality. Now you can calculate the noise. So how to calculate noise? From raw data, subtract the trend, subtract the seasonality. What you are left with is noise. How you calculate trend? Take the moving average of raw data. How you calculate the seasonality? Take from raw data, subtract the trend, whatever you are left with. For that, for each month, you take the average. That's your seasonality. Okay, and from raw data, if you subtract the trend and seasonality, you are left with noise. Is it clear, or do I explain it again? Let me know if there is any doubt. Okay, so let me just write it again. You start with the raw data. Okay, in order to calculate the trend, you in order to calculate the trend, what you do is you take the moving average of that raw data. Okay, this is how you get the trend. Now, when you from the raw data, when you subtract the trend, what you get is noise plus seasonality. Now, from this, I want to extract the seasonality. What we will do is for each month, let's say for January, collect all the January values. Okay, sum of all the January values of this. So write it like collect all the January values. So sum of R minus T values for the January month. Okay, collect all that, take the average. Let's say if it's 10 years of data, take 10. If it's 12 years of data, take divided by 12. So take the average. That is your seasonality for the month of January. Okay. Now when you will subtract from raw data, subtract the trend, you subtract the seasonality, what you get is noise. Is it clear?
Yes.
Yes, clear.
Yes. Yes. Yes.
Prabhari, clear?
Yes.
Yes, it's clear.
Okay, okay. So now we will see another part. Now we have got to know how to basically extract the trend, extract the seasonality, and extract the noise. But only problem is averaging out. So let's say, okay, I have the temperature data, okay, of 100 days. Now, day 1 is let's say 30 degree, day 2 is let's say 29.9 degrees Celsius, and so on. Okay, so I have day 100, which is let's say 25 degree Celsius. Now, can I predict as D101 as the average of this 100 days data? Can I just simply say that average of this data is the next day? Or maybe let me just say this is 5 degrees Celsius. Okay, can I just say that the next day prediction would be average of all the 100 days data? Would that be a good prediction?
No.
Why not?
It's depend on season.
Exactly. So here when you are taking the average data, you are not considering that whatever the temperature was in winter, that won't be the temperature in the summer. That won't be the temperature in rainy season. So depending on the season, depending on the uh, environment, sorry, depending on the time of year you are in, the temperature would be very different. So you can't use the summer data in order to predict the temperature in winter. So many times the average data doesn't produce the good results, as we give the actual weightage to all the past data. So here we are considering all the past data, and that's why an averaging the values won't give you the good results, because the summer data won't do much better in the predicting winter data. So averaging out the temperature for 100 days to calculate temperature today is a really bad idea. So in the past few days, but instead if you give more weightage to past few days data, then it could lead to a good prediction. So that's why they came up with the idea of simple exponential smoothing. So instead from average, um, from so from moving average, first we saw the technique of moving average, right? It didn't give us very good results. So that's why we moved towards another one, which is exponential smoothing. So we move towards exponential smoothing. So many time average data doesn't produce good results. So what we want to do is uh, we want to come up with some better technique to find out the average values, right? So that's why we came up with simple exponential technique, simple exponential smoothing. Okay. Uh, this focuses more on the recent data than the entire local average. Sorry, entire instead of entire average, this focuses more on the local average. So the idea. Now let me. So let's say this is the data. Let's say we have the data of temperatures for 100 days. Okay, 100 days temperature data I have. Now what I'll do is I'll calculate the local average. Local average. Now my local average will depend on two factors. What was my local average yesterday and what is my temperature today? Okay, today's temperature and yesterday's local average. This is the these are the two values that will help me predict the local average today. So in order to predict L100, you just simply alpha into L99 plus 1 minus alpha into T100. Okay. So what is the temperature today? and what was the local average yesterday, that would give me the local average today, and this would be your prediction for tomorrow. So T 101, this would be your prediction. Okay. So how would I calculate L99? L99 would be equal to alpha L98 plus 1 minus alpha into T99. So let me just start from L1. Okay. So for L1, just before the L1, so actually the L1 would be alpha L0 plus 1 minus alpha into T1. Okay. Now we don't have this value because there is no data before it. So L1 is nothing but T1. L1 is nothing but T1 for that matter. Or to be precise, 1 minus alpha T1. Now your L2 would be equal to alpha, then your L1 plus 1 minus alpha into T2. Now you have the L1, which is we have calculated. You have the L2, which is given to you, which is the raw data. Okay. And then you will calculate L2. Similarly, you will calculate L3, L4. Like that, you will calculate L99, which is alpha L98 plus 1 minus alpha T99. Okay. This can predict, this algorithm, it can predict only for one day. So that is, so but when you will calculate L100, that would be your prediction for day temperature at 101th day. Okay. If you want to calculate on the second day, you would predict it as the same. Okay. For the second day, this is not a very good prediction, but that's what we do. So on the second day also you will predict it as L100. For first like 101th day also you would predict as L100. 102th day also you will predict as 100, and all your predictions will be L100. This is not very good method, this is very simple method, but because here we are not considering any seasonality, any trend, we are assuming that there is no trend over the data, but but there is no such data where there is no trend or seasonality. We will see how to improve this model, but as of now, this is the thing. So you will be predicting your next day value based on your local average for the previous one and the today's temperature data. Is it clear? Any confusion till now? So in order to predict, so L100 would be your prediction for the next day. In order to do that prediction, alpha L99, this is local average till yesterday. Yesterday's local average 1 minus alpha today's temperature. This will give you the temperature for tomorrow. Remember, this model assumes that there is no trend, no seasonality. Therefore, it doesn't give the good output, but this is the simplest algorithm, so that's why we are studying. And we will basically build on top of it. Alpha here is hyperparameter, and we know how to choose the hyperparameter. This is classical model, and we improved this model over time. Okay, any doubt till now? Any part which is not clear? Clear, not clear?
It's fine.
Mahesh, how about you?
Yes.
Okay. Now, if we plug the values for L100, right? So your alpha L99 is nothing but your alpha L98 plus 1 minus alpha 1 minus alpha into T99 plus 1 minus alpha T100. Now again, if we plug the value for L98, we would get so if I write it properly, alpha square L98 plus alpha into 1 minus alpha T99 plus 1 minus alpha T100. Now again, if I substitute for L98, you will get um, 1 minus alpha T100. This value I'm writing first. Then alpha into alpha 1 minus alpha T99 plus you will get alpha square 1 minus alpha into T98 plus alpha cube 1 minus alpha T97 and so on. So basically, if alpha is equals to half, let's say, so your L100 would be equal to 1 minus alpha, sorry, alpha we are taking 1 half. Okay? So your L100 is nothing but half into T100 plus 1 by 4 into T99 plus 1 by 8 into T98 plus 1 by 16 into T97 and so on. They did nothing much, but they took the weighted average. Okay. Instead of, so earlier what we were doing is we were giving same weightage. We had 100 days data. We were giving same weightage to the data today and same weightage to the data on the first day. Okay. So instead, what they did is they reduced the weightage over time. So if your data is very old, your data will have very less weightage than the data which is very new and relevant. Okay, so as we go back, information will become relevant, and that's why you multiply it with the factor which is lesser. Okay. Now, next part is the double exponential smoothing. In the double exponential smoothing, this is for the data that has trend but no seasonality. So, data has trend but no seasonality. Okay? The data has trend but no seasonality. So, earlier we were predicting using the local average, but then if there is a trend, local average will not work. So that's why what we do is, so let's say you bought something today for 2 rupees. Next day you bought it for 3 rupees. Day you will bought it for 5 rupees. Next day you bought it for 6 rupees. What is your prediction of the next day? What would be the prediction for the next day? Just looking at the trend. Yes.
Eight है.
8 कैसे होगा? हाँ, okay, 8
No,
8
eight
भी हो
not होगा.
Okay, let me just make it more simple. Okay, now you tell me.
7.
Correct. What you did is you saw how much is the difference each time. You added that much difference in order to get the next value, right? Similarly, if there is a trend in the data, let's say your raw data was T1, capital T1, T2, T3, up to T100. Okay? Your local average is L1, L2, L3, up to L100. Okay? Then let's say your trend is T1, T2, T3, up to T100. Now, your 101th prediction would be equal to L100, which was the prediction that we were giving earlier, plus your trend, right? Because every day the trend is different, so plus your trend. Now, 102th value, what it would be? It would be L100 plus T100 plus T100. So, L100 is 2 times T100. Like that, you will do the prediction. Now, here there is a slight different way of calculating L100. Earlier, what we were doing is we were just considering that there is no trend, there is no seasonality. Now we have the trend. So, in order to calculate your L100, what you do is alpha L99. This is as it was, okay? The local, uh, yesterday's local average, but you will add the seasonality of yesterday too in the while calculating the local average, and plus 1 minus alpha T100. So all we are doing is we are just including the seasonality in the calculation. So this is the best we can do basically given the data, given the trend. Okay. So we won't, so this was our earlier prediction, alpha L99 plus 1 minus alpha T100. Okay. But we won't do this anymore. Okay. We won't do this anymore. We will, this would be required because of the trend. And how we calculate T100 trend, how we calculate? We will have some hyperparameter beta and we will do L100 minus L99. So today's local average minus yesterday's local average. So change in the local average plus 1 minus beta into yesterday's trend. Okay. So let us calculate the values. Let's say first the trend was 0. Okay. Because on the day 1 there would be no trend because we don't have any previous information. The trend value is 0. Then your L1 will be equal to T1. Okay, because you substituted, there is no local average before that. So let me write alpha L0 plus T plus T0 plus 1 minus alpha into T1. Right. Now both of these values are 0 because there are no values before t1. So your L1 will be equal to 0 plus 1 minus alpha into t1. Now you have this value. Now from that, if you calculate t2, your L2, your L2 will be alpha L1 plus t1 plus 1 minus alpha into t2. Now your t1 is 0, so your L2 will be alpha L1 plus 1 minus alpha t2. Now how you would calculate t2? T2 would be equal to beta your L2 minus L1 plus 1 minus beta into T1. Okay. So then you substitute the values. Beta L2 is alpha L1 plus 1 minus alpha T2, and your L1 is 1 minus alpha T1. So put those in the equation, and what you will get is, so you will put those in the equation. This value is 0, t1 is 0. Okay, so your value will be beta L2 minus L1. So like this, you will keep on predicting. Similarly, you will calculate the other values. So the kth prediction. So now once you have all the values, you have the values for L100 and you have the values for T100. Now kth day prediction would be equal to L100 plus K into T100. Okay. So basically this is nothing but trend is like change in the local average. So it depends on two things: change in the local average and uh, trend up to yesterday. And substituting these values, and in the case of calculating local average, just we are going to add this trend part. Is this clear? Is this clear? Yes, no.
Yes.
Now if you understood this, the next part is very easy to understand. The next part is known as halt. This is called Holt-Venus model. Though it's written as Winters, it's pronounced as Venus. So Holt-Venus model. Let me just write down what all we'll learn today. So let me first summarize what we did. First, we saw simple average. In that, what we did, in order to calculate your L100, you just gave equal weightage to all the previous values. And so on. Okay? You gave weightage, equal weightage to all the previous values. But then we saw this is not a very good way of doing things, because majority of the time your data won't be dependent on 100 days back data, 200 days back data, and here you are giving equal values, equal weightage to all. So this is not a good way of doing things. So we move to the simple exponential. Here what we said is we would give more weightage to the recent data. So half of the weightage would go to the recent data. Then we will go on reducing the weightage. Okay. So more weightage to the recent data, and we assume that data has no trend, no seasonality. Then the third, we went to double exponential. Okay. So we had this L100. There we had data. We added the term T99. This is this we are adding the trend into the data while calculating the local average. Here how we calculated local average? This would be equal to alpha L previous local average plus temperature of that. Here we are just adding this extra term of the trend. Everything else would be. And how we calculated this trend?
वो बीटा क्या बोली तूने? बीटा
Huh?
बीटा बीटा क्या मतलब क्या है बीटा का?
It's a hyperparameter. We will choose that parameter based on your data. Beta will just tell you which component to alpha, and beta will tell you which component to pay more weightage to. इस पे ज़्यादा weightage देना है या इस पे ज़्यादा weightage. So beta would be so L300 L99. So you want to focus more on the change in local average, or you want to give more weightage to temperature today, yesterday. So if you keep beta close to 1, this term would be almost 0 and more weightage will be given to. If your beta is very small, then this term would be negligible, and this term would, you will give more weightage to this. Clear?
Yes.
Let me just clear this. Okay. Now, if you have understood this, you shouldn't have any problem in understanding part where we just add another term, which is seasonality. Now, till here we were assuming no trend, no seasonality. This is just the simple average. Then here also we said no trend, no seasonality. Here we said trend but no seasonality. Now we are saying inverse or triple exponential. Here we are saying there is a trend and there is a seasonality. Let me just show. So this data has both trend and seasonality. So you have L100. So what was your L100? L100 was nothing but alpha into L99 plus your trend, and then alpha 1 minus alpha, and then your temperature, right? Is T99, oh sorry, T100 T100 temperature today. Now here we are gonna subtract the seasonality. So in the first time we added this into the local average. Now we are gonna subtract the seasonality from our current data, today's data. We are gonna subtract the seasonality. This is the only difference. Now let us see how it basically will change the. So our T100 is same, okay, no change over there. It's beta L100 minus L99. So look, change in the local average plus 1 minus beta into temperature, yesterday's temperature, previous day temperature. Now what is S100? That is the only thing left to be discussed. So let me take another hyperparameter. So it is nothing but change. So temperature today, subtract the local. Okay, let's write it. So you had L100 equal to alpha L99 plus T99. I don't know why it sometimes happens with this. Suddenly it deletes all the things. Anyways, so you had L100, okay, which is uh, your L99, which is your local average yesterday, plus temperature, sorry, not temperature, trend of yesterday, plus 1 minus alpha, your temperature today, minus the seasonality today. Then we know how to calculate the trend. How we calculate trend? Change in the local average, change in the local average plus yesterday's temperature. Okay. Now how we calculate the seasonality? It's nothing but take another hyperparameter. So y100 minus y, sorry, we had taken t instead of y. T only here. So T100 so T100 so you have delta. This is a hyperparameter T100 minus local average of today. T100 is nothing but temperature today minus today's local average plus 1 minus delta, and then your seasonality of period. For example, if you are calculating, so your data is like this: January, Feb up to December, then again January. Okay, so if you want the seasonality for this, okay, here you substitute the seasonality for this. Are you getting my point?
Yes.
So this way our prediction will be L100 plus N into T100, sorry, N into T100 plus seasonality 100 N minus P. P is nothing but period. I just wrote this as a same thing. Just wrote it as a equation, like just generalized the equation. So first we start with simple average. Then we say no, that is not the correct way to do it. We need to give more weightage to the local data. So we came up with the simple average, simple exponential. Then in the simple exponential, what we did is we added this term for the trend. Okay, yeah, we said that is not correct because we have not considered trend or seasonality. So what we will do is we will add the, in the local average we will add the trend term in order to get the correct prediction. Then we said no, that is also not correct. Only substituting trend is not correct either. What we need to do is we will also need to incorporate the seasonality. So then from the current data, we subtracted the seasonality, and what we got is the. Now we have all the things in place. We have the trend considered, we have the seasonality considered. So this data, this prediction would be much better than the prediction that we will get earlier. Is this clear? Any doubt?
The last column part came from where?
This prediction.
Yes.
So earlier what we were saying is L100 is my prediction. Okay.
Yes. Yes.
Then we said if you want to find the prediction of, let's say, 2 days, you add the trend into that.
Okay.
Correct?
Yes.
If you want the prediction of the next nth day, what you do is L100 plus N into T100. Correct?
Okay.
Now we are saying don't just do that, also add the seasonality. If you want the
Okay.
seasonality of the let's say fifth, so fifth day, so 105, and from that you subtract the period, so you will get the seasonality. So for the seasonality of 100, you just incorporate this seasonality. Understood?
Yes. Yes.
So earlier we were saying our local average is our prediction. Then we said local average, local average plus your trend is the prediction. Okay. Then we said no, local average plus trend plus seasonality is your prediction. Clear?
Yes.
So this is all to it. We can now, actually we can quickly go through the code. Uh, I'm just gonna see the tell you the visualization today. Not gonna because too much for one day. So we will just see the visualization and then we will be done for the day. So tomorrow we will then look into the just let me just share you the files. A second. Just upload this notebook visualization and upload the data daily or minimum temperature. Let me know once it's done. Let me know once it's done.
Over.
Huh?
Over.
Okay. So first we are importing libraries, pandas, matplotlib. Then we are reading the CSV file, daily minimum temperature. This is a temperature data. Now you can see this data is of the 10 years. So there are 120 data points. This data is of the 10 years. Then, okay, so there are 3,650 samples. So this is the 10-year data. That means, and it is recorded for each and every day. So as considering 365 days a year, this 10-year data from 1981 to 1991. So 10 years of data you have of the daily temperature. This is the line plot. Now you can see in the line plot, you can see for the winter the temperature is low. Then again in the summer it increases. Again the low. So you can see the seasonality. Okay. Now this histogram and density plot is not much. Skip that part. Here you see. Okay. Yeah, I just format. So here, first we are reading the CSV file, and then we are telling it that group it as a like by year. Okay, it's annual data and group it as year, and then we are plotting the box plot. Okay, so for 1 year, whatever the data is, you want to find out the box plot for it. Now you can see almost the median is same. Okay, and you can see some outliers, but yeah, the median is same. This is how actually they study the global warming data. They have the data of, let's say 100 years, and then they will see if the median is shifting uh, by, like, if the global temperature is rising. So like that they find out. So here you can see median is almost more or less same over the years. Okay. Now another interesting plot is the lag plot. What is a lag plot? This a plot basically. Okay. Firstly, this will help you understand mean over time. But the lag plot, this graph will show you how much today's data is related to the data of yesterday. Okay. So um, so let's say if the data is like this. Okay. So y1, data is like this, and your values are 1, 3, then you have 2. Let's say this is the data. Now you have uh so first your v1, which is value today, or then how your value is that compared to that of yesterday. Okay. So that, let's say today value is 1, yesterday value was 3. Today, let's say yesterday value was 3, so day before yesterday value was 2. Then day before value was 2, and just before that the value was 4. So you are basically plotting today's value with yesterday's value, today's value with yesterday's value with day before yesterday. So you are basically plotting that in order to see how, if there is any kind of correlation. So this data will tell you today's data, yesterday's data, how they are correlated. Are they positively correlated? Are they negatively correlated? Or if there is no correlation. So you can even check if I keep lag is equals to, so if I keep lag is equals to 2, then you will get lag, lag equal to 2, then it will compare the today's value with day before yesterday's value. So it will compare the 1 with 2, 3 with 4, 2 with 3, like that. So lag will be 1. So today's value will be compared to day before yesterday. Yesterday's value uh, just 2 days before that, like that. And if you compare the lag of, you can see it's almost like there is no correlation, a random scatter point. So, but if you see lag 1, there is a positive correlation. If lag 2, there is still slight positive correlation. This basically tell you how much 30. So it has it is plotting the correlation. Okay. So with different lag, we are plotting the correlation. Lag plot will just tell you how today's data is correlated to yesterday's data. So is there a positive correlation, negative correlation, or there is no correlation? Tell you. So is this clear till now?
Random का
Hmm?
here random, where is a random? It's kind of positive correlation. No?
This is positive correlation. I'm saying this is more of a random.
Hmm.
This is positive. This is definitely positive. Actually, you don't need to go by the gist. You can actually calculate the correlation, right? That's what we have done here. So calculate the correlation and find out actual, uh, like fit the linear and then find out.
Right.
So clear till now?
Yes. Hmm.
Tomorrow we will see how to code the part because there is not a lot to it. But today I think we have studied a lot of things. So let's not get confused with that. So tomorrow we will see. So today's model, whatever we saw, are the data-driven models. Tomorrow we will see model-based uh, forecasting. So it's not that complicated, but so let's do that tomorrow, and we will also see the coding part. Okay, coding part for the forecasting.
Right.
Hello.
Okay, 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 okay.
Uh-huh. Okay.
Yeah.
Any doubt till now?
नहीं नहीं लग रहा.
Okay then. So we'll see you tomorrow.
Okay.
Good
Bye.
day. Good day.